Welcome back to the second part of this three-part tutorial Python project. As I've mentioned in the previous part, if you have not seen the previous part, go watch that first before moving on. In this part, we will discuss about the data preprocessing and the data transformation. In the previous part, I've shown you the data set, how I've converted the data set into two different data sets. In this part, we will be looking at the code for this project. As you can see here, this is a IPYNB file. This is a Jupyter Notebook extension. In the GitHub file, you will find a Python file. I haven't uploaded this one, this Jupyter Notebook, because this is for understanding it. The Python file contains all the code in a single flow. As you can see, Jupyter Notebook helps us create different cells to help us understand the code in a better way. So let's start with the Python code here, Jupyter Notebook. Let's start with the libraries first. As you can see here, we are first using the pandas library. You are probably familiar with this library. It is used for data storage and data manipulation. It helps us. It has many existing functions that help us in our pre-processing steps. There are two different statements here. The first one makes sure that we don't see warnings when you use different functions like LOC or ILOC to print different parts of the data. You may see different types of warnings there. This line helps us ensure that we don't see those warnings, and this line will help us show the whole row rather than some words. If you, as you can see here, if I show you tweet.head, you'll probably see 7 or 8 words and the rest will be removed. This will help us show the whole row. As you can see here, we have used the RE library, which is a regular expression library, which will help us clean or perform pre-processing, as I should say, clean different types of words, digits, special characters. And the next library is Word Ninja. Word Ninja will be used to expand munched words. Let's suppose we have two words combined. If someone writes something offensive and combines two words, it will be difficult for us to check if that word is offensive because it is combined with another word. Let's suppose we take an example here. So we add car and fast together. Let's suppose fast was offensive. Our model would not detect that and it will go undetected. So it helps us break that word down into 2 different or 3 different or 4 different words based on probability. And the next library is NLTK. NLTK is a really powerful NLP library. It has multiple tools. The one I'm using is tokenization to break the words down into different tokens. We have next library contractions. Contractions help us expand words like, let's suppose we have a word aren't. It will expand that into are not. Then we have Vader library here, Vader sentiment. It will help us perform the sentiment analysis and output the result in a number ranging from -1 to +1, -1 being the negative and +1 being positive. And we have sklearn library here, in which we have imported like the train test split, which will help us divide the data set into training and testing data. We have imported different models here: naive Bayes, SVM, logistic regression, random forest classifier, k-neighbors classifier, extra tree classifier. I will not be going over these models and what they do and how they perform their task. I will just mention their metrics, which are our evaluation metrics, which are F1 score and the accuracy. And then we have the MySQL connector. I've stored all the data set and different types of lists, which I will mention later. In a database, you can do the same, or you can store them locally or in a CSV file, that is up to you. Then we have the last library which we have used, which is called pickle, which helps us store the results of our model, so we don't have to run it again and again, or it takes a lot of time to run the code from start to finish. So it helps us store results of our model, so we can start the model and start predictions without running the rest of the code from the start. You will explain this, you will understand it easier as I go through this code and I explain it to you. We will connect it to our MySQL server with different parameters. Again, you can skip this. You can store these files in a CSV or a text format and pick them up from your local, from your computer, rather than storing that into an SQL file. As you can see here, this is the text on which we will be performing data preprocessing. This is taken directly from Twitter. I saw this read and it is definitely offensive. So I took it from there and I'll show you through each cell how we perform different preprocessing steps. All right, so here we have imported the first data set, which helps us determine whether a tweet is considered offensive or not the one which helps us determine the type of the bullying present. As you can see here, the tweet is present here. This is the second data set, which determines the type rather than determining whether a tweet is considered or a text is considered as offensive or not. We have visualized the data set here. You can see the data set is pretty balanced. There are equal amounts of classes are present, yes and no. And again, equal instances of classes are present here: age, gender, religion, and ethnicity and race. So what is the benefit of a balanced data set? Why do we need a balanced data set? When we will split the data set into training and testing data, we need to make sure that the data present is balanced, like the classes are present in equal amounts of instances. So why do we need it? We need to do it because if the data set is imbalanced, meaning that it has unequal class distributions, the model's performance metrics may not accurately reflect its true capabilities. All right, which means that the model might achieve high accuracy, predicting the majority class while ignoring the minority class, and it will definitely be biased towards the class which is present in majority, and it will accurately it will always predict the majority class while ignoring the minority class because it is biased towards it. Let's suppose we take a data set and we distribute it into 95 and 5%. 95% goes to one class and only 5 instances goes to the second class. The model will be biased towards the 95 instances of classes while ignoring the 5 instances of different classes. And if we check the accuracy, it will accurately determine the 95% while incorrectly determining the 5%, and it will show us the 95% accuracy, which will be good, which is good, right? Because it is 95% accurate, the results are 95% accurate, but it is not right because it will ignore any of those 5% class distributions. In if it sees the unseen data, if it is deployed, it will ignore those and predict them as the majority class. So let's start with the data preprocessing. As you can see here, the first step is we convert all our characters into lowercase. As you can see, this was the original tweet. If I can show you where it is. Yes, yeah. You can see there are multiple uppercase characters here. These are converted into lowercase, and here we are using the RE library, the regular expression library, to clean, add different special characters, digits, the word RT, links, etc. As you can see here, there was a as you can see, there is a exclamation mark here, which is removed here. There's a link here. I inserted this link here just for the example purpose, for example sake, that it completely removes the links, because we are not bothered by those links. We aren't expected. These links are completely useless to us because we can't extract much information from them, so we just ignore them. As you can see, you are, this is removed here as well. Different characters are removed here. That comma is removed here as well. So it helps us clean the characters or different digits very quickly. Then contractions are expanded. UR expands to UR. And in the next step, as you can see here, we have different slangs present here. This is a list. You can see here, these are the slangs here, and these are the expanded slangs. You can see we use in our daily communication, we use different slangs. So the purpose is to expand these slangs to get as much meaning as out of these sentences as possible. As you can see here, there are multiple instances of the same code. You will find this pattern throughout. The first one is for the as you can see, data, which is the which shows whether a tweet is offensive or not, which was a binary classification problem. And the second one is classify data, which shows the multi-class one, which determines the type of cyberbullying present. And the third one is our tweet here, which we are processing the pre-processing on. The reason why I'm not showing you the data set here after each step, because the data set is really massive and it creates confusion, like what am I performing, or what step is actually happening. So this is why I took a single text and I'm performing each processing step on it so you can understand it better. As you can see, we have at a slang list. All of these lists, by the way, will be present on the GitHub page. You can download them from there and start using them from there as well. As you can see here, if there are any if there are any slangs present here, they will be expanded here. In the next step, we will use the word ninja library to expand munch words. As you can see here, this word was expanded to this. As you can see here, it did a great job, expanded that expanding that word into 2 different words. Then in the last step, we will create tokens of this sentence. As you can see, it has created tokens here, and all of the words, as you can see here, everything is clean. There are no special characters. There are no digits. There are no munched words. Like, we have completely cleaned and pre-processed this, and obviously we can use it now to for our next step, which is the data transformation. The data transformation will be used to convert our data from textual format to numerical form, because the models we are using accept data in numerical form rather than words. So we have to convert them first into those numbers into numerical form. As you can see here, offensive is severity, which is a word list containing all the offensive words and their respective severity with it. And obviously the negation word list, this is another word list that I've used. Negation will be used to if a offensive word comes up, and if there is a negation behind it, it will negate it, meaning it will not consider it as offensive. And as you can see here, we will calculate the total words here, the total tokens. There are total 14 tokens here, and we will extract the offensive words from it through the help of this word list. And then the respective severity. As you can see here, we have the severity column here, severity of the word, of the offensive word. And then from that, we will calculate our first field or first attribute to feed our model, which is the density. Density, as you can see here, we can calculate density by calculating the total amount of offensive words divided by the total number of words available. The second feature to feed our model will be the sentimental analysis, which we will perform, as I've told you earlier, with the help of the Vader library. As you can see here, we performed the analysis and it gives us a minus 0.75 score, which I've told you before, it ranges from -1 to 1, -1 being negative and 1 being positive. And then as a last and the third feature, the third and the last feature of to feed our model will be the weighted average of the severity. Whereas you can see here, we have severity here present here. So we need to calculate the weighted average. When why do we calculate weighted average? We calculate weighted average when we have values and their weights assigned to each value, because each value doesn't have the same weight, they have different weights, so we have to consider their weights as well, rather than just calculating the average, which is adding those numbers and dividing it by the total numbers. We can see here there are 3, 3 and 5. You can see here the 3, and the 3 will be added. 3 has the 3 weighted average has 2 instances and the 5 has 1. So 5 plus there 2 of 3, which will be equal to 9. Yeah, as I was telling you, 3 will be added with 3, which will be equal to 6, which will be added to 5, which will be equal to 11. And then the total will be divided by 3, which means the 11, which we have calculated earlier, will be divided by 3, which will be equal to 3.666. And through these, we have calculated the 3 attributes, the 3 features to feed our machine learning model. In the next part and the last part, actually, we will discuss how we will be training our machine learning model and how we will evaluate those to check if those are giving satisfactory results or not. Thank you for watching.